Hello everyone, here is FRQ number 1 from the AP Calculus AB and AP Calculus BC exams in 2024. And make sure to check the description below where I've provided links to the College Board website where you can see this FRQ. So let's get started. Here is problem number 1, and it says the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. For 0 is less than or equal to t is less than or equal to 12, selected values of c of t are given in the table shown. In part A asks us to approximate c prime of 5 using the average rate of change of c over the interval from time values of 3 to 7 and show the work that leads to your answer and make sure to include units of measure. So for this, I would set up first a difference quotient for c prime of 5. And since we're approximating it, I'll go ahead and use the approximately equal to symbols. And it already said to use the interval from 3 to 7. So I'm going to use these 2 points. So I would have c of 7 minus c of 3 divided by 7 minus 3, which is equal to 69 minus 85 over 7 minus 3, which is equal to negative 16 over 4, or negative 4. And because this part says to include units in our answer, this would be negative 4 degrees Celsius per minute. And there is the answer to part A. Moving along to part B of number 1, it says to use a left Riemann sum with the 3 intervals indicated by the data in the table to approximate the value of the integral from 0 to 12 of c of t dt. And then we'll go ahead and interpret the meaning of that other integral next. So first, let's approximate the integral from 0 to 12 of c of t dt. Now it says to use a left Riemann sum with the 3 subintervals. So as you can see, the first rectangle of our Riemann sum would have a base of 3, since we're going from a t value of 0 to a t value of 3. And the height, I would want to use c of 0 because I am calculating a left Riemann sum, so I want to use the height on the left side. The next rectangle would have a base of 4, since that's the difference between 7 and 3, and a height of c of 3. And then finally, the last rectangle is going to have a base of 5, since that's the difference between 7 and 12, and a height of c of 7. So I can put that, or I can plug in these values. It would be 3 times 100 plus 4 times 85 plus 5 times 69, and that comes out to equal 985. The next part says to interpret the meaning of 1 over 12 times the integral from 0 to 12 of c of t dt in the context of the problem. And that integral represents the average temperature of the coffee from t equals 0 to t equals 12 minutes. Now on to part C. It says for 12 is less than or equal to t is less than or equal to 20, the rate of change of the temperature of the coffee is modeled by this c prime of t equation, where c prime of t is measured in degrees Celsius per minute. It asks us to find the temperature of the coffee at t equals 20 and show the setup for your calculations. So we need to find c of 20, and I'm going to use the net change theorem. So I'm going to start with c of 12, or the starting value, and then I'm going to add on the change in temperature from 12 to 20. To do that, you would add on the integral from 12 to 20 of c prime of t dt. Now we know c of 12 is 55, and we know that because we are given that here in the table. And then I need to add on the integral from 12 to 20 of c prime of t dt, and I'm going to go ahead and just keep it as c prime of t dt since c prime of t is defined in this problem. And so when you calculate this in your calculator, you would get 40.329 degrees Celsius. And by the way, this question number 1 is a question that you were allowed to use your calculator. And then finally, part D. And it says for the model defined in part C, it can be shown that c double prime of t equals this equation, and for time values between 12 and 20, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate, and give a reason for your answer. So this question requires us to evaluate C double prime at t values between 12 and 20. So if I think about plugging in values of time between 12 and 20 into this second derivative equation, well, plugging into this exponent, e to any power is always going to be positive. Plugging the time value into here, 100 minus a value between 12 and 20 is also going to be positive. And then finally, we are dividing by t squared, and any value of time squared will always be positive. So as you can see, we end up with all positive values. So I'm going to write that C double prime of t is always positive or greater than 0 for time values between 12 and 20. Therefore, the temperature of the coffee is changing at an increasing rate, since the second derivative from 12 to 20 will always be positive. So that's it. That's question number 1 from the 2024 FRQs from AP Calculus AB and AP Calculus BC. We'll see you in the next video. Bye.